Okay, you're turning in homework 9 tonight. Please talk to me after class if you're having trouble finding your .pde file and uploading it. That's what I want. Grab that .pde file and upload it just like you normally would any other C++ program. Homework 10 is now online and it's due on next Monday. Bless you. And the goal with homework 10 is to start using objects in your processing sketches. And you're going to see, I think, in a way that's not as cool as it's much cooler than C++ about how you use objects in a graphical environment. And in fact, it's debatable that that's really why object-oriented programming has survived as long as it has, because it works really well in graphical programming environments. So that's what I'm going to do today, in fact, is build a class that will represent a bubble. And we'll start out really simple with just a bubble, and it's going to be a circle, and we'll show how to draw it. And then we'll actually add some physics to the class that lets it sort of float upwards. In the middle sometime we'll get Sarah to come up and tell us about Google's search algorithm. And unless there are any questions about anything. You have a program due tonight. 2 maybe. Emily.
For the final exam, how would you say it's weighted between C++ and processing?
The final is cumulative.
Right.
And half of the final will be on topics from the first 2/3 of the class.
Okay.
Sort of the review stuff. And then the other half of the final will be on stuff from the latter third of the class. About half of that maybe is processing.
Okay.
So a quarter on the new C++ stuff from the last exam. Other questions? The format of that exam will be very similar to prior exams. The latest homework will have you drawing balls that bounce. So you're going to have this app, and when the user clicks on the canvas, a new ball will be created, and it will fall to the ground under the force of gravity. And when it hits the ground or a wall, it will bounce off. And you can put as many balls on the canvas as you like. And we'll be using an array object. In fact, I think I'm going to change this. We'll keep it as an array object, I guess. We'll use an array object to hold all of the ball objects. And then there'll be an above and beyond opportunity, and the possibilities for above and beyond in processing are just really limitless. And then I'll ask you to put your sketch on the web. For example, the sketch that I'd like to finish with today, I put on the web earlier this morning. That's this guy. Pretty simple. Just randomly creates bubbles of a certain size, and then they float upwards. And as they float up, their radii expand a bit. Okay. So part of your homework assignment will be to put this sketch on the web. I think I have. Bless you. I think I have. Yeah, there's a video here on how to put your sketch on the web. So watch that. All right. Without further ado, let's talk about classes and objects in processing. Yeah, okay.
Why does it bring balls practically on the thing?
Oh, does anybody know the rest of that quote? My dad used to say it all the time. Dylan, you're smiling like you might know it. No?
No, I have no idea.
Okay.
I'm just surprised that.
If I had 2, I'd be king. You know that one, Jordan? Yeah, it's a good one. My dad used to say it all the time. Okay. Let's save this. you can see I've already been working on the bubbles thing, but I've moved it out of the way. Okay, we want to draw a bubble. First thing I'm going to do is let's get a blue background for the water that the bubbles are floating in. So we have these two primary functions, one to initialize everything, the other to repeatedly draw on the canvas at a very high rate. We have to set the size of the canvas. Let's just make it something like 500 by 500. So like that, and that's probably good enough for now up there. And let's get a blue background. So we'll do, say, background. Let's make it 200, 200, and 255. So that's going to give me a kind of a light blue background. Let's see if that's indeed the case. Oh, thank you. Okay, light blue background. How do I know that's light blue?
You can use your color tool.
I could use my color tool. You can think of, another way to think of it, Kendall, is you can think of it as having 200, 200, 200 there, right? Now, if it was 255, 255, 255, what would it be? It would be white. If it's 200, 200, 200, it's close to white, but not quite, so it's a light gray. And if I hike up the blue slot a little bit, it turns the gray a little bit blue. So that's the intuition that goes in there. All right. How do we want to represent our bubbles? Well, there are a lot of different ways to do this, but fundamentally what we're going to be doing is drawing circles on the canvas to represent bubbles. But what I'd like to do is build a class to represent bubbles. And inside the class, I'm going to have a constructor. And the constructor is going to go as follows. It's going to have an initial x position, an initial y position, and an initial radius. And what will happen in this 3-argument constructor is I'll just set the x equal to x init, y equal to y init, and r equal to r init. But at the moment I don't have any class variables, so let's give this class some variables. Float x, y, r. What do you notice already a little bit different about processing classes versus C++ classes? Dylan?
Well, you don't have to declare. Like, I mean, okay. That's fine.
No public and private section. That's the big difference. There's no public and private section in processing. You have class variables and you have the constructor. What makes that a constructor is that it's a function with the same name as the class. So that rule still holds from C++. But what's different is there's no public and private section. Everything can be accessed using the dot operator in processing. So this will create a bubble. What I would like to also do is let a bubble draw itself. So I'm going to declare another member function, and I'll just call it, I don't know, render, say. And it's not going to take any arguments, and it's not going to return any values. But what it will do is draw itself at the particular location. Well, we decided that we were going to draw these things as little circles, so let's do that. So we're going to make an ellipse. The center of the ellipse will be the x and y values of the class variables, or the object variables, and the radius, the width will be twice the radius, like that. Now, at the moment, I've got a bubble class, but it's not doing anything. I've just got the plain old blue canvas. And it won't do anything until I actually create some bubbles in the bubble class. So let's do that. We'll go up top here. Remember up here, if I declare variables out here, they're global variables. They're accessible within any of the functions that follow. So let me declare a bubble variable, a bubble object, B. And let's go into setup and actually give it, allocate the space for it. And let's put it right in the middle, 250, 250, and let's give it a radius of, say, 10. Remember, in processing, when you declare a variable, it's a two-step process in general. Up here, we give it a name and a type, and down here, we actually allocate space for it. Two-step process. We've got the bubble. Let's go down here and make the bubble draw itself. And this is going to happen over and over and over again. It's going to be boring. The bubble's just going to be a circle sitting there. But you'll see how it works. So let's save this guy, play it, and there's the bubble. The bubble object is declared once, it's allocated once, and then it just draws itself over and over and over again. That's the render. If you would like to tweak, say, the style of the bubble, you can go down here, and the nice thing about the way we've written this is everything's kind of encapsulated. If we want to change what a bubble looks like, we should make changes to the render function, right? So let's make the bubble, say, have a white boundary. Let's make it a little bit of a heavier stroke, so make it 2, say. And let's have no fill. Make the bubble seem a little bit more transparent. Notice I didn't have to make changes anywhere else to change the style of the bubble. I just changed how it draws itself. So that looks a little bit more like a bubble, perhaps. Okay. Now what I'd like to do is make this guy float upwards. And I don't really know perfectly well the physics of bubbles, but they tend to sort of start at the bottom and maybe accelerate upward, at least to a certain extent, and then but they do kind of slow down, and we're not going to get into that really sophisticated physics. Well, what I want is a bubble that sort of floats upwards and kind of accelerates as it goes. And this is one of my favorite things about processing and this object-oriented approach, is we can actually simulate kind of Newtonian physics in a really simple and intuitive way, and in a way that for people who have had physics in this class are really going to like. So I have my position, x and y. I'm going to give myself a couple of more variables, an x velocity and a y velocity, and an x acceleration and a y acceleration. Okay. And down here in my constructor, x and y are set, r is set by input from the user. I'm going to give myself an initial velocity of 0, and so let's put that in here, initial velocity, and I'm going to give myself an initial and in fact a constant acceleration. Acceleration, constant, and in the up direction. So that's going to be AX. There's no acceleration horizontally, and AY. I know this from experience that a good number is around 0.03. And then what we can do is simulate this kind of Newtonian motion. And it's really cool the way it works. So void will say move and the way Newtonian motion works is you add the acceleration in the x direction to the velocity, the acceleration in the y direction to the velocity, and then you add the velocity in the x direction to the position and the velocity in the y direction to the position. So the AX and the AY are changing the velocity. That's what acceleration does, right? Acceleration changes velocity. And then the velocity, the Vx and the Vy, are changing position, because that's what velocity does. It changes your position. And it changes it in this very clean and linear way. So now I've got this move function, and every time I call it, it updates the velocity using the acceleration, and it updates the position using the velocity. So now, instead of just rendering myself, I'm going to move myself a little bit, and then I'm going to render. Or I'll render and I move. It doesn't really matter which. So I'll draw myself, and I'll move myself. And I'll draw myself, and I'll move myself. Starts out slowly and accelerates. Let me put it a little bit further down. Maybe down at 50-50. Oops. Dummy. Thinking the wrong way. 250, 450. Yes, that's better. So you see how it kind of starts slowly and then goes off quickly? You'll notice that if I knock this down a little bit, say down to 0.01, then I'll get a slower acceleration. The acceleration, negative 0.01. Does that make sense? Negative? Because that's the negative y direction, right? The acceleration in the x direction, it doesn't really make sense, but if I wanted to, I could add some acceleration in the positive x direction, for example, like that. If I do that, what's the bubble going to do? It's going to shoot off to the upper right, and it's going to accelerate in that direction. Here's an interesting thing. What if I change the initial velocity? Let's give it an initial downward velocity of, say, 1. Nah, let's make it 2. And let's change AX back to 0. What kind of behavior will we get now? It'll go down a little while and then it'll go back up. Right, because the initial velocity is it's initially down in the positive y direction, but the acceleration is in the other direction. And so we should see it dip down a little bit and then go up. Went down pretty far. Need to move it up a little bit. Okay, so I'll move it up a little bit. let's make this, I'm just guessing here, let's try 200. Very cool. And that's just constant acceleration. You can do all kinds of different kinds of accelerations, sinusoidally varying accelerations. Anyway, let's just leave it at that for now. Any questions about that? It's remarkable how easy it is to simulate some of these Newtonian mechanics in this program. Yes?
Suppose we were to something like graph, we couldn't just type in 9.8 because it's depending on the frame rate.
It totally depends on the frame rate, and the units here are really pixels, not feet or meters. So that's why I said I know from experience that negative 0.01 or negative 0.03 kind of works. You just sort of work with the frame rate that you have, the hardware that you have, and you play around with the numbers, and you get something that works. And the main takeaway here, at least for this particular value, is that this is the sort of order of magnitude of values that you should play around with. And you'll figure out really quickly what are some good, sensible values that look natural. But that's a good point. We're working in kind of a units-free environment. The units are pixels, and the time unit is frame rate. And you can actually make sense of that. You can kind of do calculations and think carefully about it. Mostly I just play around with this kind of stuff so much that I know what are some reasonable numbers to try. Other questions? Okay. Sarah, how about you talk to us about your question, and then we'll go on and talk about making arrays of bubbles. So, you want to log into something?
Yeah, I emailed myself a PowerPoint.
Oh, good. Let me log out of my thing. Okay. It's all yours. Let me know when you're ready.
Okay. Should I download it or just view it?
I guess you can download it. Do whatever. Yeah, then click on that, I guess. Come on, stupid computer. Oh, what's that right down there?
That would be
Okay.
the PowerPoint. View. Do I just click view? I have no idea.
I have no idea. I don't think PowerPoint.
Okay.
Slideshow.
Oh, awesome. From beginning. Google search.
Yes.
So Google search starts with they create a database, and they use spiders and crawlers to do this, and they're little automatic programs that they go out to the 30 billion web pages, and they kind of crawl all over them, and they follow links from page to page to kind of create you can imagine the web, and they're going through it, and they look at what links to what, and they add these to what they call the index, which is just a huge accumulation of what are all of the pages and what do they link to. And Google used to do this. They'd do the entire internet all in one chunk, and this would take about 30 days. But by that time, things had changed. So now they do it in little chunks, and they do one chunk of the internet and then update their index and kind of go that day by day. So you're not getting out-of-date information. And their index is over 100 million gigabytes, so it's huge. So they have a lot of algorithms that they use. When you type in your search function, they look at how you spell the words, and they'll suggest options. I mean, you all use Google, and you can see that they do that. And they also look at synonyms for words to try to get better matches to your searches. They also have autocomplete, where they drop down menus to see, guess what you're looking for. And then Google Instant is where if you hold your mouse over the link, it shows up the page of what it is. So that kind of is supposed to speed up your search. And then they pull pages from the index based on how they match your search terms. Okay, and then Google ranking, one of their first algorithms and kind of their big algorithm is PageRank, but they have over 200 factors by which they rank their search results, and the factors are constantly changing based on new ideas they get. So site and page quality is essentially they look at what does the content of the site and how does it match what you're looking for. And this is kind of a big part of their PageRank algorithm. And PageRank looks at what sites link to your site and are those sites reputable sites. And the more links you have from reputable sites, the higher your page quality is, and thus the higher your rank. Freshness is essentially like when was your site updated, and the more recently your site is updated, the higher your rank score gets. Safe search gets rid of like unwanted content like porn and anything like that. Yeah. User content is essentially they look at your past searches and try to match your current searches to things that you're looking for now, so using your search history to get a better search for you. Translation means we'd only be getting primarily sites in English, so they look at the languages of the sites to get that better. And then universal search is the way that they combine images, videos, and links all into like a streamlined result page. And then spam, they have a lot of algorithms that fight the appearance of spam. Most of this is removed through all of their searching algorithms and PageRank and everything. But also if spam is appearing in their search results, they manually remove it. So they're doing like test searches a lot, and then if the stuff is coming up, they will remove it from their results. And if that happens to your site, they do notify you, and then you're allowed to change your site so that it's no longer considered spam. And then you can update them, and this just keeps your search results relevant. That's the end. But I did use this really nice graphic. I don't know if this is going to work.
Sure, say yes.
Okay. But it's this really nice like infographic that it's like you can click on it and scroll through it. Scroll. So crawling and indexing. And you can go through. It's really interesting, but there's a lot more details. So.
Question? Spiders and crawlers. Crawlers follow links, but do spiders?
I think they're pretty much the same thing. I looked at like this one, this infographic made by Google only mentioned crawlers, and then another website mentioned spiders, but didn't really go into detail about it. So I think they're similar.
I don't know the difference.
Yeah. It might just be two names for a same thing.
One of my relatives used to work at a company where they try to get their company to show up on Google, and I think they were doing keywords. Do they do that anymore? He'd like go in and like misspell a bunch of words in like invisible font at the bottom, so it'd come up under different searches.
Yeah, Google is combating things like that. So that's part of their spam filters, is getting rid of like invisible words and stuff. Like if it does appear in invisible font, their like spam filters will get rid of that.
Yeah, it's the friendly name for that industry is search engine optimization. And there are reputable firms that help you get your web page ranked highly on Google, but then there are somewhat disreputable firms that try to game the algorithm to get. I mean, you know, talk about monopoly power. If somebody searches for, I don't know, somebody types the word book in, and then Amazon is the first hit or something like that, right? I mean, if you can be that first hit, it's going to mean millions or billions to you. And so, and there are examples where Google will change its PageRank algorithm a little bit, and a company that was at the top suddenly doesn't even make the first page, and the company's out of business in a month. It's really remarkable the power that Google has in their PageRanks. Other questions?
Yeah.
I heard that Google also, one of their factors for like page ranking was however many people clicked on the link.
I think that's kind of like a part of it. That's part of PageRank. There's not I mean, everything I found on PageRank is kind of confusing or contradictory because they're like secret, secret
they do keep
programs.
track of after a search, if you click on the first link and then you don't click on any further links, Google will note that as a success. But if you click on the first link and then you click on like the third link and then you click on the fifth link and you're scrolling down and you go to the next page and you click on that, that's a failure of the PageRank. And Google's algorithm is going to keep track of that.
The thing I heard was it was some internet group abusing it, and like I think it was for some politician. They like all went to a certain page and made this like ridiculous page the first thing on Google.
Yeah, the Santorum incident.
Yeah.
Yes. In fact, I think if you type Santorum in, no, we're not going to do it. The first hit is pretty rude still.
Okay.
So, and yeah, but that's the power of the people, I guess.
Yeah.
Hundreds of thousands or millions of people went through and basically upvoted this search term, and Google's algorithm, being somewhat impartial, and again, I don't know if Rick is still up there, or if that alternate definition of Santorum is still up there, or if Rick Santorum is now back at the top, or what. Yeah, it's an interesting thing. There are lots of interesting sociological phenomena that you can read from Google search results. I was just listening to a piece on, I want to say it was on Radiolab, but it might have been on Freakonomics, where you type in a person's name, and one of the things that comes up on the side are ads for public record searches. And it was Freakonomics,
Yeah.
and they were typing in, if it was a black-sounding name, the record search would offer you arrest records. But if it was a white-sounding name and it was just a more generic ad for the same company, like you could find more information about this, or did you go to the same school? But if it was a black name, you want the arrest records? And the explanation was that it was the algorithm, that when people were typing in black-sounding names, and then at first the ads were sort of just randomly cycling through these banners, but what happened is the black-sounding name pulls up this list of ads, and more people were clicking on the arrest record ad than anything else, and so it got associated with these black-sounding names. It's a terrible thing to say about our society, I suppose, that happens. But it wasn't intentional as near as they could tell. It was just a result of the algorithm. There are good and bad things about these algorithms. Okay, thanks, Sarah. All right. I love Freakonomics. And I love Radiolab. Okay. Now, typically when you're dealing with bubbles, there's more than one. So what I'd like to do is show you a way of dealing with lots of bubbles at the same time. All right, so now this leads us to the notion of arrays. So up here we have one lonely bubble. Better to actually have lots of bubbles. So I'm going to get myself an array. And I'll call it bubbles. Now remember, it's a two-step process, so we declare the array up there. Down here, we will allocate the array. So bubbles equals new array. And I'm going to be storing my bubbles in the array now, so I'm going to get rid of this bubble variable and just have an array of bubbles. Let me put a bubble in the array. So let's do bubbles
new bubble, and we'll say 250, comma 400, comma 10. Now there's a lot going on here. There's the array, there's the .add member function, which puts whatever's between the parentheses, it puts it into the array. And then what's in between the parentheses is actually a bubble object. But we don't have to store it in a variable and then put the variable in the array. We can just create the bubble right inside the add function, and it will insert it into the array. And I can see that guy. Let's go here. I am going to actually keep my bubble variable, b. And what I'll do is I'll get that bubble out of the array. Bless you. I'll get that bubble back out of the array. I'll render it and I'll move it over and over and over again. Let's see if this actually is functioning before I start talking further about it. Array.
Shouldn't it be like int bracket?
No, this is a general array. I might have to use ArrayList. Let's use ArrayList. I don't know why array isn't working though. Let's use list. Let's see if that works. Okay, so we still have our initial velocity downward. So instead of using array, use ArrayList. I can't remember why I've mixed that up or what that should be. Let's change the initial velocity to 0. Save it. Okay, so it's effectively the same. But what I've done now is I've given myself a container that can hold lots of bubbles. So up here in setup, instead of just one lonely bubble, we can add a bunch of bubbles. Say, let's get an int up here. For I equals 0, I less than 100, I plus plus, I'm going to add a new bubble. It would be kind of boring to put all these bubbles at the same place, however, so why don't I kind of randomly place them? And a good random x position would be between, say, 0 and 500. And a good random y would be the same. And let's keep the radius the same for the moment. So after the setup program is finished, instead of having just one lonely bubble, I will have 100 bubbles, all randomly placed on the canvas. Now I get down to the draw command, and instead of just drawing one bubble every time, I need to draw bubbles over and over and over again. So I'm going to loop through the list. And do this kind of thing. So instead of one bubble at position 0, I've got 100 bubbles from 0 to 99. And I have a for loop, and I'm going to go through and extract each bubble. I'm going to draw it, I'm going to move it, and then I'm going to go on to the next bubble. And every time I draw, I go through the whole array. So this is happening a lot, right? This is happening 30, 40 times a second. I'm going through the whole array of 100 bubbles. I'm rendering them, and I'm moving them. Let's see what that looks like. And there they go. Simple enough. Let's talk a little bit about syntax. The array list is a little bit different from a regular array. You don't get at things using the square brackets and the I. Instead, you use this .get member function with an I. But other than that, it's about the same. And then the other thing is, unlike C++ arrays where the type of thing that the array is holding is fixed, processing arrays can hold any type. So I could put a bubble in one slot, and I could put a ball in another slot, and a bubble and a ball, or two balls and a bubble. The downside is I, as the programmer, now have to know what particular thing I'm drawing out of the list. So I happen to know that this is a list exclusively of bubbles, but the bubbles array doesn't know that it holds bubbles. It just knows that it's holding these objects, some mysterious objects. So when I get a bubble out of the list, I have to cast it. And that's what the parenthesis bubbles thing is doing. It's saying this thing that you just got out of the list, it's a bubble object. If I don't do that, it'll just get confused about render and move. It won't really know what kind of object you're dealing with. So that's another subtlety of processing versus C++. Okay, let's see if we can keep this going a little bit. How about we start with a really small radius and let it grow? So let's start with something like a 1 pixel radius and let the radius grow. How do you think we can make that happen?
Connected to acceleration of velocity.
Or I could even introduce a new.
But like related to that.
Right. So I could introduce a rate at which it should grow. And then I could do the same thing that I'm doing with the velocity and the position. I could increment it each time by that rate. Let's do that. So I have an R variable here already. What would be a natural variable name for the rate at which the radius is increasing? Mathematicians? dr? Yeah, dr. And we'll just make a guess here. I don't have a good intuition about how quickly this should grow. Let's make let's just make a guess here. Let's try dr equals 0.1. Do we want dr to be positive or negative?
Positive.
Yeah, we want the radius to grow, not to shrink. So the radial rate of growth. And then how should I now make the radius grow? Following this example right here. In particular, the move thing. Yeah, stick it. What?
Set R equals to R plus equal. Yeah.
Yep. Simple as that. We should now have growing radiuses. A little bit fast, but not bad. And there they go. Okay, makes sense? It's kind of sad that they all go away. It would be nice if we could kind of keep them coming. So let's change things a little bit. And instead of just generating 100 at the beginning and walking away, let's say we randomly generate one here. Say if random 100 is less than 50, then I'm going to add a bubble. And now I don't really know how many bubbles I have, so you might be able to guess that there's a member function that will tell me. So I start out with 100, and then every time I go through draw, which is quite often, I am going to randomly add a new bubble. With what probability? Random 100 gives a random number between 0 and 100, right? And 50 is halfway across that interval. So with 50% probability, every time I go through the draw function, I'm going to generate a new bubble. This might be enough to keep it sustaining at some level. Let's hit play here. Now, the longer I run this, the slower it's going to get. Why? I'm not getting rid of the bubbles that went off the top. We can do that too. So after we render the bubbles, what we should do is go through the list. In fact, I'm just going to copy this list and remove stale bubbles. And by stale, I mean the bubbles that have moved off the top. What's a way of checking whether a bubble is stale or off the top? What's a condition? Yeah? Close. Don't forget about the radius. But close. So if y plus r is less than 0, there's no point in drawing it anymore. So if y, sorry, not y, let's get a bubble first. If b dot y plus b dot r, what am I doing there? What's with the b dot y and the b dot r? Yeah, I grabbed a bubble, and now I want the y coordinate of that bubble, b dot y, and the current radius of that bubble, b dot r. If that is, what, less than 0? I don't want it anymore, so I'm going to remove it. And this is the cleaning stage, so I don't need to render or move. I'm just cleaning. So I go through, after I'm done rendering and moving and all that sort of stuff, I go through and I see if there are any stale bubbles, bubbles that should be removed. And this will stop the wasteful aspect of this program of drawing bubbles that have passed out of the screen. And that's pretty safe. I mean, that can run indefinitely now without soaking up too many computing resources. There are still lots of things that we could do to play around with this, but you get the basic idea. Yes, Chris?
You said it would slow down over time if you just kept being better than the next one's bubbles. I would expect crash after a certain amount of time? Why would it be slow?
Well, it'll slow first, and then it'll crash. It'll run out of memory. And then it's really just a matter of how well your operating system handles applications that try to grab all of the system memory. We'll talk more about this on Wednesday and how to make these things bounce a little bit.